Welcome to The Code. Construction, design and engineering. This is India's #1 construction podcast.
Hey guys, we are back with part 2 of our conversation with Jyoti Ramalingam Punaswamy, and we were discussing the performance testing in the first part. Performance testing of door windows, facades and hand railings. But now we want to move on to a different segment altogether within the testing realm, where they are testing fire safety equipment as well. So basically elements associated within fire safety, and it's not just a door, but there are other elements within the fire safety installation systems. So that is a whole different avenue. That is why we've split this into two, and this is the second part that you're watching. Sir, welcome back on the second part. And we are.
Thank you very much.
Why don't you explain what the testing is about and why is it different than what the first part was?
Yeah, thank you very much. Again, it's a pleasure meeting you.
Yeah.
Fire, as far as an element, is a very, life is, without fire, there's no life. But on the other hand, once it goes out of control, it becomes life-threatening and a disaster. It becomes more critical now because of these high-rise buildings. Now, as you go taller, the fire which we are used to when we are kids, we used to see fire engines rushing by. They go and spray water, douse the fire, rescue people. Now, that cannot happen about, let's say, 30 meters in the biggest cities. In the smaller towns, your access is very limited. Maybe 2 floors, 3 floors. Beyond that, you cannot expect the fire department to come in. So the building itself has to be designed to become fire resistant with two different very, very critical aspects of fire safety. One being active fire, which we are normally used to. Like, for example, I ask you, if I say fire safety, what's the first thing that will come to your mind?
A fire hose and a extinguisher.
Exactly. So fire hose, extinguisher, pumps, backup generator, these smoke sensors, these are the things which are called active part of the fire safety, where they need extra power in the event of a fire to do something, to douse the fire.
Okay.
And they get triggered off by automatic or manual, whatever be it. Now, there is another very critical part of the fire safety which we are not yet used to, we are not using it very widely, which is called the passive fire safety. Now, these passive fire safety products don't move, they don't need any extra energy or extra power to operate. They are built into the buildings when the construction happens. Now, their entire role is during the fire, the worst event that can be anticipated, they are supposed to stop and box the fire in a compartment, prevent it from spreading out of a certain zone to the next floor or the floor below. Because then it becomes manageable. And the active systems are functioning over there, and those will douse the fire. Eventually, the fire department may come and also help. But it gives time for people on the top floors to escape safely. Evacuation is the key. Life safety is the key. So, the products that we are talking about as passive fire safety are supposed to compartmentalize the fire. Now, you may ask me, like, what are these products?
So, I think what you're saying is it's kind of like creating a cage for that fire.
A box.
Where the spread is limited within that box or within that cage, and people movement or material movement or whatever is happening for safety is happening in the different areas of the building. That is what the passive fire safety is.
And this includes fire and smoke. Very critical. Because 85% of the fatality happens because of smoke. 15% through the fire itself. So, and it spreads faster. Like, for example, smoke can spread from the duct, air conditioning duct. So, let's say in an IT office, you have 20,000 square feet of a floor plate, 30,000 square feet, and the fire is happening in some corner, and you have partitions all over through. Now, suddenly the smoke starts coming in another direction.
From the vents.
From the vent. People don't know where the fire is, so they sometimes move towards the fire.
Yeah.
So you need to have a system where that fire does not escape through that vent and reach another place. So there are automatic dampers which get triggered off. The minute there's a fire and that heat sensor gets the temperature, it shuts the block.
I saw a system, I think that's based out of the UAE or Dubai or some city, where it was a glazed system. And I think that is what they were replicating and showing, where the spread of the fire was not possible.
Yes.
And the dowsing systems were within that area.
Oh, yeah.
And these are the susceptible areas in a building environment, areas susceptible to a fire, where they have the power units, where they have a bunch of other heated machinery, and especially during those peak heat months within the conditions that Dubai has.
Yeah.
And I remember showing it to a friend of mine who's into fire safety, and I'm like, okay, is this possible in India? He said these are extremely expensive systems, but yeah, they will eventually come to India.
They have come.
They have come.
They have come.
And I'm talking about like 2-3 years back, so I'm not sure
Yeah.
what. And
So if we are talking about passive fire, let's say a simple product that we all are aware of in passive fire is the fire door. Now,
absolutely, yes.
the fire door is located in the fire escape. And if you see the fire door, you have a panic bar, which means you can open it from inside, but you can't open it from outside.
Yeah.
For opening from outside, you have a typical handle. But from inside, you just hit it, the door opens. But 100%, it has to close back.
Yeah.
And when it closes, it should not allow smoke to go out.
Yeah. And it doesn't open from outside.
Yeah, it can open.
It's only one way.
Yeah, it opens only this way.
Yeah.
So why fire door? Because people are escaping through the fire escape route, and that particular area needs to be free of smoke. So typically in a modern building, you have high pressure. You'll get fans which will pressurize that zone, so that the smoke doesn't enter. Even if it's a little bit of a smoke trying to escape through the gap, it doesn't go into the common area, escape corridor, because that pressure is more than this pressure. So there are automatic fans which will start working to pressurize this zone. Now these doors, typically we are used to is metal doors. Now what you are talking about is the glazed doors.
Yeah. Wooden and glazed and
Wooden. In any hotel, if you go in a reputed hotel,
you'll see it.
the door which is there on a room is 1 hour rated.
Yeah.
Because if there's a fire in the corridor, for 1 hour you're safe in your room. And National Building Code has changed a lot, updated itself. But yet there is a long way to go. But yes, we are moving in the right direction.
In India, isn't it like a 4-hour standard?
No, 2 hour rating.
2 hour standard?
Yeah, 120 minutes is the rating
120
for
minutes.
smoke and fire.
Okay.
Critical thing is all the escape corridors, all the doors facing the escape corridors need to be fire rated.
Yeah.
Because in a large office, you have several different locations.
Yeah.
If one place is on fire, only the smoke is retained in this area. The rest of them, people are walking, running through the escape corridor. They should not be affected.
Right.
So the mandate is that all the doors which are facing the escape corridor needs to be fire rated.
Right.
Now, if you have brick wall, is fire rated. No questions about it. A fire rated metal door, fire rated. But people don't want to have complete wall and just like a red door or a green door, because then aesthetics is also important. So therein comes this glazed fire doors and glazed partitions. On a normal day, it looks like a normal partition. The glass looks like a normal glass. But in the event of a fire, that glass will not allow the fire to come out or the smoke to come out, because the glass itself is got a gel. It's a sandwiched panel with 2 glass panels, and there's a gel which is reacting to heat. So the minute heat reaches a certain stage, the inside glass will crack and the heat will hit the gel, and the gel will become opaque. It won't be clear glass thereafter.
Okay.
Become opaque. So it does 2 things. One, it stops the heat from reaching the second glass, thereby creating an insulated barrier. So this surface will become not so hot, so that beyond a certain temperature it will crack.
Yeah.
So to prevent that, this is protected. Number 2, radiation. Now what is important in fire is that you have, let's say you have a fire rated glass. Earlier we used to have a borosilicate glass, clear glass, which is fire rated. So for 2 hours, the temperature on the other side is 1000 degrees. the temperature on this is normal. But the glass becomes so hot that the radiation from the glass will burn this.
Yeah.
And you'll have spontaneous combustion, because from there, this carpet, once it starts getting heated up, in 30-40 minutes, the temperature is so high on the surface of the carpet that it will, without a light, it will catch fire. So the fire starts spreading from here. So that is called spontaneous combustion. So there are two components to that fire glazing. It's called integrity and insulation. So, and radiation. So there are three specific classifications of glass. One is called E, then EW and EI. India has chosen to go with the EW, which is not the other extreme, not this extreme,
Yeah.
where the radiation should be less than 15 kilowatts per square meter and 2 hours rating. Now, if I say this is my product is 2 hour rating, how do you prove it? You have to actually put it through a test.
Yes.
So we are having a laboratory where we have a furnace where there is a time temperature curve. Universally, all over the world, you have a time temperature curve, and that's called, there are different curves for different applications. The typical thing is a cellulose curve.
Yeah.
So at the peak, at 2 hours, the temperature is around 1070 degrees, starts from 0, and it moves in a particular heat pattern. So we have to have a heat burner, kind of a burners, which are getting a feedback from the thermocouples and increasing and decreasing to maintain that curve. And there is a plus or minus band. So we have to be within that band. So the sample is put in that furnace as one of the walls, another being closed. Burners are heating up, and there are sensors or thermocouples inside which are measuring the temperature. We measure the temperature, and then the burners maintain the pressure, time temperature curve, and the pressure inside the furnace also is very critical. Maximum pressure at the top of the sample needs to be no more than 20 Pascal, and at the bottom it is 0, and then minus at the ground level, and the bottom of the sample 0 and 20 maximum. So these two have to be controlled, very, very sensitive, because when you say 20 Pascal is just like that is 20 Pascal.
Okay.
So why 20 Pascal is that the burners are blowing heat, the air and LPG or whatever is the fuel you're burning, and because of that positive this thing and the flue gas going out, there's a pressure inside which is less. So all the flame, if there is a, let's say, a failure in a door, because there is no pressure inside, the flame starts to get sucked inside. So even though the door is a failed product, it doesn't appear to be failed.
Yeah.
So it gets passed. So unless you test it properly, you can't say that this product is qualifying the requirements. So in door is a typical, then you have fire rated partitions. Then you have penetration seals. So what are the penetration seals? Now you have all these service ducts in a building. They are the weakest spot in the entire building, because you may have a fire in the 5th floor. The fire enters the duct. It's a closed duct.
Yeah.
Starts moving upwards, and it enters into the 7th floor or the 20th floor or 30th floor. Even in Mumbai, there was a recent accident where some fire happened in on 10th floor. One person who was working on the 22nd floor died, because the smoke suddenly came in through the duct, service duct, which he was not prepared. Inhalation, he had carbon monoxide, he fainted, and he died there. So now the mandate is that every floor you have to seal after you install the pipes, the risers, the water pipes, and whatever services are going up. Typical system, what they do is that they cast slabs. After you put the pipe, you cast a slab, believing that the RCC is fire rated. RCC, yes, it is fire rated, but the weak spot in it is that now we are using UPVC pipes. So if you have a fire, that fire will burn through the pipe and come up and keeps going up. So you have what you call as a penetration seals, which are wraps before the pipe and after the on both the sides or in the middle in the RCC. These are intumescent strips which are wrapped around. So when that fire reaches that and the intumescent strip is exposed to the fire, it expands 25 times its thickness.
Okay.
So you have, let's say, a 2 mm thick wrap which you have put 4 times. So it's 8 mm thick. It will expand. So it can't expand outwards because it's retained by the concrete. It compresses the pipe and stops the oxygen from reaching. Thereby the fire will stop penetration. So these are called penetration seals. So typically, well, like we said, the compartmentation, the National Building Code says 700 square meters minimum you have to break it in 700 square meters. So that periphery above the false ceiling must have vertical barriers closed, and all the penetrations which are going through must have some form of a protection on either side, so that fire happens that side, it doesn't come to this side, from this side it doesn't go to that side.
Okay.
Because otherwise, typically you see a large office, you will have many partitions, but the partition only reaches up to the false ceiling. Now if you open the tile and put your head through, it's one big hall.
Yeah.
So fire doesn't have anything, the minute one puncture happens in the false ceiling, it starts spreading across that.
And out through all the vents.
Through the vents. So it starts coming through the false ceiling into places, people panic, they run into each other, they run into the fire. So a lot of things can go wrong. So those penetrations have to be all sealed using intumescent paint or penetration seals. Now all these products are supposed to be tested because it's a life-saving. It's expected.
I was just going to ask you,
Yeah, it's expected to only perform once in its lifetime.
Yeah.
But that once, it has to do it,
It has to do
thoroughly.
its job, yeah.
If it fails there, means loss of life.
Yeah.
So it's a very serious issue. So there, we test those products for the rating, how long it's lasting, whether it's failed, not failed. Because once we do that, there are two things again. One is the test itself, that is a golden sample. Now, as a testing lab, I can say this sample which came to me is good. It's performed. But I can't give a guarantee that all the products that are being manufactured in the factory is also good. Because I have no control on it.
Yeah.
Therein comes the certification, like ISI or UL or Intertech or FM. All these agencies, what they do is they just not do one sample. And that one sample also would have been picked up on a random basis from their production line. Yeah.
That's
It's
a choice by the tester?
No. The certification body will
agency,
choose it. And the other part of it is that they will also audit his factory. And therein, the certification body actually gives them labels to put on this product saying that you are certified by so-and-so agency. That means they are warranting the end customer that everything that is produced by him is of this quality. So for which there is a fee that needs to be paid, but they will do some interim audits, sudden audits. You have to intimate them if there is any change in your raw material supplier. Because you are buying from X, you start buying from Y, there's no guarantee that the same quality will be there. So he has to come, verify. You don't have to test, but at least he'll verify whether this is also equally good, whether this fellow has some traceability. So everything is under control conditions.
What is the policy in place to make it mandatory in terms of testing these things?
Testing, see in India now ISI is going to come.
It's still not
It's
there, right?
still not. For fire doors it is. Recently also they have included lift landing doors because it's a very critical component.
Very nice.
But if you say Middle East, everything related to fire is mandatory,
Yeah.
tested,
Yeah.
certified, chapa. You can't take any risk. It's a matter of life and death.
But it's not just UAE. I think that they run on global standards, and in a way, I get a feeling that they're copying the American systems.
Yeah. Americans, Europeans,
much
they
as
are
they
25 years ahead.
Yeah.
You see, despite this, you must have heard of this Grenfell Tower, the disaster that happened in London recently, maybe 6-7 years ago, which shook UK because there was 57 people who died. It's a one single building for low income housing, wherein some wrong specification was done. The fire happened in the night when everybody was asleep, and people were caught unaware. The smoke killed most of them. But the serious part of it is that the government reacted really fast, and they set up a committee, and they said like every building which has used this product, every housing society has to do a test of that combination of their building. Because one of the things that in the Europe is that you have to insulate your building. because of the weather. So insulation, they use rock wool, mineral wool, many different products.
Yeah.
So they said, whatever you have used in your building, put a similar sample, give it to the lab, get it tested, a full size, and you have to provide the certificate. Otherwise, we will not give you a renewal of your occupation certificate. You have to vacate. So suddenly there was a huge jump in the demand, thousands of buildings. And there are only 2 labs in UK. And so much so, there were people sending samples all the way to Dubai to test. Imagine, 5,000 kilometers.
Yeah.
But entirely they overhauled the system. Their fire codes, everything, they looked at it again. They changed how to make sure that things don't slip through the gaps. There obviously was a lacuna which somebody had exploited it, and that caused this. Sadly, we are not so serious about fire. Okay, we see...
Even now.
You see so many fire accidents happen here. There recently is this
Every summer there are cylinder bursts.
Cylinder bursts.
Every summer there's something.
Yeah.
This summer it was too hot. I remember like so many cases in Faridabad, so many cases in Gurgaon, Delhi, where not. And you can actually just Google it and you find all these cases.
No, you see the recent hospital infants in the incubators.
Yeah.
Some 12, 15, 20 babies just died for no fault of theirs. What happened? Short circuit. So obviously somebody has made a mistake of underrating the cable or the junction box or whatever. So it has to percolate down that whatever electric, and if you see 90% of the cause is electrical short circuit. Because we are building for one particular rating and we keep adding loads onto it.
Yeah.
And then we don't upgrade it. So the cable will get heated up and it's all behind the walls. You can't even see it. One fine day it's so hot that it will just burn and melt.
Right.
And then spread from there. And the hospital fire is very serious.
So in totality, like what all systems can be tested within the fire systems?
Let's say fire doors is the basic lowest of the thing. Fire rated partitions which are insulated. Then you have fire glazed partitions, glazed doors, windows, curtain walls. Then you have penetration seals. Then you have ducts, air conditioning ducts, dampers, which are supposed to trigger off and close.
Yeah.
Even the kitchen ducts, they need to, in the hotels, all these ducts, the grease keeps going into it. So it's a fire hazard.
Yeah.
So that is tested as per the standards. And another critical part of it is now we are getting a lot of steel structures entirely. Like for example, airports. If you see the airports, then there are no concrete columns, beams. It's all steel coming up and then steel to steel, and then roofing and glazing. So those steel structures are protected by paints which are special. Because steel has a tendency to lose its structural strength after a certain temperature. 500 degrees, 50% of the strength is gone. 750 is almost collapsing.
Yeah, especially if there's sulfur or phosphorus present in the steel.
Any steel. So structural steel is protected by what's called intermittent paints. And these intermittent paints can be acrylic based, it can be cementitious. Cementitious, like surface will not be smooth. It will look a little rough. Intermittent paint, the acrylic paints are very smooth. It looks like a wall paint. And you can color it. And once it's painted, the purpose of it is that in the event of a fire, this intermittent paint again expands like a foam, creating a barrier, insulating barrier between the fire and the steel. So the fire will not touch the steel for that given 2-hour period, by which time the dowsing would have been done. So the structurally integrity of the structure is there. You scrape off that, when you spray water, it will flow down. It's like a foam, it just flows off. Then you do preparation and then repaint it. The structure is not at loss. Another kind of a paint is the cementitious, which is more widely used in tunnels. So tunnels are very critical. Long tunnels have vehicles going in it. Suppose there's an accident in the middle of the tunnel and the vehicle catches on fire. Then the smoke starts spreading. The fire intensity is very high. So the spalling happens in concrete. After a certain temperature, concrete will start breaking up. Then the steel gets exposed. And the steel gets heated up, it starts to buckle. So the whole tunnel can collapse.
Yeah.
So there are special paints which are sprayed on the roof of the tunnel. So in the event of this fire, that will expand and protect that concrete from heating up.
Okay.
And this is, I see this is going to be a big thing, because in India now, government is investing huge amount of money into roads and highways and tunnels. And wherever these tunnels are coming, high intensity traffic. And generally, God forbid, accidents happen in the wrong place inside the tunnel, then it's disaster.
Tunneling in itself has become a whole industry in itself.
Now the technology is available. So another very critical part of where this cementitious paint is going to be used is, I see in the coming years, is in parking lots, basement parking lots.
Yeah.
Because residential apartments, commercial buildings, IT parks, malls, you have thousands of vehicles, and a high risk in that is the EVs. Their behavior is very unexpected. Nobody can predict. Suddenly the lithium-ion battery catches fire. While charging, sometimes spontaneously, some overheating happens in there internally, and these fires are what they call the intensity of the fire is much more than a typical fire, and it's very difficult to douse that fire because it's a chain reaction happening inside the lithium. The energy which is packed is far more than a normal product. Let's say you take a mass, like this will have a kilocalorie energy. If you burn it, you will release so much of kilocalories. But a lithium ion battery will be far heavier for sure, and the quantum of energy which is stored in it is like 20 times this. So when that 20 times of energy is trying to...
It doesn't extinguish that.
It doesn't. And then the closest is all the basements are low floors. You have 9 feet, 8 feet. So the exposure is very intense, and chances of slabs collapsing, columns collapsing, and it will become mandatory in the coming years to spray cementitious protection, vermiculite paints on all these roofs and columns, so that in the event of a fire, it doesn't turn into a major disaster.
Who does the onus lie on when it comes to testing the fire systems? Does it happen to be the contractor who's installing them?
No.
Is it the stakeholder of the project?
Stakeholder of the project can only ask for a test certificate as far as the product is concerned.
And that is exactly what... So there's a funny thing going on in India, especially if you want to insure a building against fire safety. They'll come, they'll give you that, sell you that insurance, not ask you for anything. But God forbid something goes wrong, and now you claim for that money back.
Then they'll say.
Then they'll ask you for those documents saying, okay, give me the fire safety thing, give me the approvals, give me the MCD approval, whatever. And they'll ask you for all those documents then. I actually had this conversation with somebody who was selling that insurance to me, and I said, okay, fine, you're selling that insurance, but why are you not asking me for those documents today? What is the basis on which you're selling me that insurance? Now, if you're insuring my building and later on when it catches fire, you will ask me for compliances then, which doesn't make sense to me.
I don't get insurance anyway.
Yeah.
So I don't get compensation.
So I don't understand what you're doing.
There is...
Just say no. And apparently it's not going to be good for him to say no or her to say no, right? It's a sale they're making. We live in a land where we will make money off it, but we will not guide that person to get the right compliances in the beginning itself.
See, worldwide, insurance is a very big business. Fire insurance is a very big business. So there is one standard called FM. Now, FM is from US, and it is actually an insurance company. They have created their own fire standards. Okay. So any product or any project which is following the FM standard and approved, certified by FM, they get a discount. And it's a billion. FM is a very big brand, and it's a $1 billion business. Similarly, UL, the insurance companies, all the big certification bodies like UL, Intertech, and then this thing Element or Warrington Fire. If you have a certificate from them, then you get a discount. because your product or the risk is lower for the insurance company. So they can give you that benefit. In India, it's still to catch on. It's still to catch on. But eventually, see, even in insurance, there are a lot of global players coming in.
Yeah.
And they will also offer the same thing. And then, of course, there's a new, that fire consultants who have come in.
Yeah.
They are professionals. They have their experience. They'll specify to the developer that you have to do this.
Yeah.
Now, I think even in the National Building Code, they are developing a requirement that the inspection has to be done by a qualified fire engineer.
Mm-hmm.
And then he has to certify, only then the fire department can sign off. Because, see, most of the time, fire department may not be the most educated or the most knowledgeable person in that, because their focus and their training is very different.
It's different, yeah.
So you have a set
It's
of
to avert
professionals.
danger and risk to humans.
Yeah.
and
Rescue.
yeah,
They're
it's
more
the
on the
rescue
rescue.
part of it.
And sadly, if you see, most of the time fire professionals, I mean our firemen, they will rush in without knowing the risks. They will just take the hose and rush in without knowing, bloody, the whole thing falls. And there was, in Mumbai, the fire chief and his assistant, number 2 in the state, died in a fire accident, supervising. The whole building collapsed on them.
Yeah, many a good men have been lost like that across the globe. But
they were trying to do that from the front because of a serious fire, and the whole thing fell. So they are putting themselves at risk without knowing what is the quantum of risk. So it's nowadays it's more that they do a study and see whether there is any risk to the people, because there is so much of monoxide fumes, and you can't just rush in because you don't have the proper equipment. It's a very serious concern. Slowly we are moving towards some kind of a safety. And
I think evolution is slow in any
but
case.
we are very slow. I mean,
it comes with experience, and it comes with hopefully
that way we are trying to play a very small part in trying to make sure that all the products which are being used,
they are tested.
whatever claims they have, genuinely whether that
they
claim
stand
is
to
actually,
do it, yeah.
because we are trying to do the test as per the specification, because sometimes the lab, if I don't do the test, then it's on me.
Yeah.
The responsibility, it's on my head.
Yeah.
Whatever happens down the line, I
Are you
don't
following
know.
European test standards then? Because
No,
you don't
there
have
are IS standards now.
There are test
Fortunately,
standards
we have adopted a lot of international standards. Earlier it was EN and ASTM, but now there are IS standards. BIS has released all the standards. And so they are also gearing up.
Can you tell us what IS codes are there, if you remember, if you don't mind?
Offhand, I can't, but there is a series of codes, because each product has a different code. For structures, it's different. For penetration seal, it's different. Door is different.
Based on the product, right?
Based on the product. And you have to get yourself tested as per that. And I am hoping that this ISI mark comes at least first, so that more people do and get some kind of an accreditation that it has been tested by a qualified person.
I think I have to give a good shout out to the BIS right now, because I think they're doing a brilliant job over these last few years.
Actually, they are on turbo. In fact, they are behind most of the committees.
There is no system that they're leaving behind. I love it. Like in terms of specifications, they're on point. The guidelines are clear.
You can
step by step, everything is mentioned.
In fact, you can see so many advertisements where they say this product is like from now it doesn't have ISI because they have taken a random sample.
It goes into public issue.
It comes in. Your reputation is at stake.
Even if you just go to the website, mention the IS standard, you can actually download it by just creating a basic account.
No, you are free.
And it's free.
Just put your mail ID. You can get any Indian can download it.
Any ID you use and create an account and download the specification, read and go through it. Not just as a consumer, but also as a B2B person, like somebody who's within the business of that. I think everybody should sort of read through the IS standards. It's not a very long sort of document कि ऐसा नहीं कि 200 pages आपको पढ़ने हैं. I think within those 5-10 pages, there is that in-depth detail about everything that you're trading or you're manufacturing or you're promoting.
And how you can align yourself with the requirement.
Absolutely. And they are spot on. There is a good amount of research that has gone in. Industry experts have joined hands and given those inputs.
You'll be surprised if you send a query to BIS. you'll get a response
good
within 2
response,
days.
yes,
It's not like a typical those days, government, you write one way, just keeps going, nobody's caring about it. No, they are very, very responsive. So even like industry professionals, when they say or write to them saying that world over this is being followed, we are not following it, immediately they try to get the committee to look at that genuinely whether this is suitable for us, and they make a change in the thing, put it for open circulation, and make changes faster.
I want to ask you one last question about this, and it's same to what we asked in the first part. So testing in lab versus testing on site. Now this is about testing for fire.
Yeah.
Now testing on site
Can't be done.
That's impossible.
It's not possible. Because you can't create this much of temperature.
So basically what we are doing is we are trying to create a foolproof system as much as we can.
Absolutely.
And then testing it through the lab with that right simulation in place and hope that it works.
Yeah, because this one in the lab, the temperatures are really high. Okay, it goes to 1,200 or 1,100 something in 2 hours.
So
a
the
typical
conditions
fire,
are harsh, basically.
A typical fire flashover is around 900 degrees. Worst come. And then, of course, there are special fires and special tests for the petrochemical industry.
Right.
And there are special tests for shipping industry. That's all. Each of them, railways has a different set of tests. But we are talking about construction, which is a cellulosic curve. And the requirements are, for all products, is the same curve.
Yeah.
But doing the test, you'll know where you stand. And if you have to make some changes, improvements, you might as well do it, because it's not one time. Once you do it, unless you change anything in that product, you can carry on with it for a long time. I think ISI is coming up with a requirement that once in 3 years, you need to send a random sample for testing. Because not, I myself have seen some of the fire door manufacturers, they have a certificate of 1980s.
Oh.
It's on the wall, along with the grandfather's photograph.
That's like 50 years now.
Yeah. We have tested, sir, 1985, my grandfather tested it. Now I'm making the same door today using that certificate, which is not, because the world has changed. Your methodology has changed, your raw material changed, your cost
changed.
Yeah, so
Tech has
you need to
changed.
do
The
at
way
least
you're
once
doing
in
it
3
has
years
changed.
if you're manufacturing. So that's a very critical part of it. But I see that because now there's a proactive thing rather than a reactive thing. So, and now because of media, if there's a fire accident, everybody knows about it.
Can I be honest with you? Like, I think I would never get into a business which holds so much responsibility, especially towards someone's life. I'll be scared.
Yeah.
A company is not built out of just one person's vision and dreams. It's about those hundreds of people working towards that common goal, and those values need to be intact. Plus, that drive to actually deliver with that responsibility felt on your shoulders to make it safe for the other person, because it's a very, very big undertaking, and I'm glad that I'm not in a business where I have to be responsible for other people's lives.
Absolutely. It has to come from within you.
Yeah.
If you're in a business where your product is going to determine the life of some unknown person somewhere many years down the line, you have to take, to the best of your ability,
You need to take that responsibility.
make sure that you are buying the product which you genuinely
And
believe.
you don't compromise on values just
Exactly.
for. It's a very big divide between empathy and being a capitalist. Like where you need to just put a hard stop and say no.
Yeah.
You know what, we
So,
cannot do this.
It's not like buying biscuits, okay, so this biscuit, you eat that biscuit. The taste is a little more, salt is more, less. Doesn't make a big difference.
Absolutely.
But here, in its lifetime, that product needs to work only once.
Yeah.
And if it doesn't work, it could be the cause of a big disaster.
If it works, I think the world will know. If it doesn't work, still the world will know.
Yeah.
So it's better to do it right.
But then everybody goes, the one who breaks or takes it casually is the one who thinks chance of a fire is 1.1%.
Hota hi nahi.
And even if the fire happens, who's to find out that my product only failed?
Yeah.
Immediately you can say that failed, this failed, that failed, try to put
I mean, I
point
think
in all other directions.
in this direction, I think it's the policymaker that has to enforce the law.
It's a,
And the
see, you have
hammer
to tie
needs to
up
be.
all the ends.
Yeah.
There should not
Absolutely,
be anything in between where people can take advantage of this. So as long as this is watertight,
I mean,
the end product will be good.
I don't know, if you've manufactured a good product but it's not installed properly, then again that's a challenge.
Most of the manufacturers insist that their quality, their team
Does the installation.
and even the end user also insists that approved vendor, approved installer only does it, because
They know how to do
you
it.
don't know how to install it. You do some half-baked stuff.
Yeah.
It will still fail.
Yeah. This is happening across the building materials industry,
Yeah.
by the way, including cement, including basic commodity items like those, where companies are running these drives to teach the user of that product how to use it properly.
Yeah.
आप बिलीव नहीं करेंगे सर, आज भी सीमेंट इंडस्ट्री इज टीचिंग मिस्त्रीज हाउ टू मेक दैट राइट मोटार, हाउ टू मेक दैट राइट
Very necessary.
concrete.
Because they are making a good product.
Yeah.
Ultimately, they are not doing
If it doesn't
outside.
work, they blame the cement.
More than blame, there's a failure.
Yeah.
So something is going to happen.
Both sides.
Somewhere somebody is going to get it. So in fact, like large companies, I could say, like, for example, Shobha developers, they have a Shobha Academy
Yeah.
in Bangalore, and they, for a small fee, 6 months training, they put through a series of training programs for masons, tilemen, electricians, plumbers, all tradesmen in the site. And without that certificate, the tradesman cannot enter a site, Shobha site,
Without that.
without that. Project manager's responsibility.
Brilliant.
So, input is so beautifully trained that your output will be, perfect.
Yeah.
They are ensuring that they control this, because the man is one key link. You may have the best material, but finally it's the human being who's going and
I
doing.
think the bigger you get, the bigger responsibility you get.
Yeah, their model is, I would say, admirable. I don't know. Maybe like L&T also, I think, has
Of course they
one
do.
such training college. But many more such people have to come, because it's like the good olden days. You had the truck driver who had a cleaner. The truck driver himself was learning from his ustad, who was when he was the cleaner, the ustad was the driver.
Yeah.
That fellow, he has learned the wrong rules. He is in turn training this fellow. He is in turn training. So you have a whole bunch of people running around without knowing what the rules are.
Absolutely.
What does this this particular board say? Kuch bhi ho yaar.
We're playing Chinese roulette with knowledge.
Exactly. So the people who suffer are on the ones on the road. So
Thank you so much, sir. It's been an informative session.
Thank you very much for the opportunity.
This is fun talking to you. If you have any questions, write to me at India's #1 construction podcast @gmail.com. You can follow me on Instagram at India's #1 construction podcast. We are available on various platforms now: YouTube, JioSaavn, Amazon Music, Spotify, Apple Podcast, Audible. I think I left something out. So just check it out and give us a shout out. If you have any questions, please write to us. Thank you for tuning in. Have a great day.